Mexico, and you know, we've made a trip home to the States to visit family, and now we're kind of in our final prep phase.
Okay, great. Okay, then we have Chad and Nicole. Hey guys, where are you? I see a nice glistening on your forehead, so you're somewhere in the tropics too.
Yes, we are. We're in Panama.
Okay, where exactly in Panama?
The Pearl Islands right now.
Okay,
So.
fantastic. Who else is coming in? We got Alan joining us. Hey, Alan, how are you? Where are you?
Hey, good morning, good afternoon. Alan here in Las Hadas, Manzanillo, Mexico.
Oh, fantastic, Alan. Good to hear. Thanks for being on the call. Then we got Mark. Then we got Mark here joining us.
Hey, it's Mark from Serenity. Things are still good here in Biazance Beach by Capos in Costa Rica. Just super hot, and I wish I had an affordable air conditioning unit to cool me off. But that's just incidental.
Yeah, well, I figured this is the height of the season, so may as well get it going, right? Then we got Peter Kent down here. Ahoy, Peter. Where are you? How are you doing? You look like you're inside somewhere.
I'm sorry, were you speaking to me?
Yes.
My audio was coming up slowly. Fine, thank you. Nice to meet you.
Good. Where are you?
Jersey City.
Okay, copy that. All right. I think the rest of the folks will be tracking in, so I'm going to start slowly introducing Archer Power Solutions, which we have Tom up here in the corner, and then Onat. He's standing in his laboratory, and I'll just go over this again. We met briefly at the Annapolis Boat Show, and I'm going to leave it at that. I'm going to turn it right over to him. He has screen sharing capabilities, and I'm going to make sure that he talks to us a little bit.
Great. Sure. Hi. Thank you, Captain Dietmar. Welcome, everybody. I'm looking sideways here so that I can see some screen share as well. So we have never done this before. So bear with us if there are any technical glitches here and there.
Ask if your audio is okay. Can
you guys hear me okay?
We hear you loud and clear, 5 by 5.
Okay. This is great. So maybe the best to hold any questions to the end so that we can run through with basic demo and some background. We're just to give you a little bit of snapshot, as Captain Dietmar mentioned before, we're a bunch of electronics and engineering geeks, basically, but our difference is we have both. And we have a talent pool which brings together engineering backgrounds in HVAC design, electronics, software, defense, and aerospace sectors together. Today on the line, we have Tom Lind, who leads our engineering and production, Yvonne Thurman, who our head of operations and finance, Peter Kent, who leads our customer service, and I believe Lisa Rubino, who leads our marketing and communications, might be joining afterwards as well in a little while. Folks, traditional marine air conditioner companies are stuck in the past. We want to be at anchor and not be miserable. We also don't want to run a generator, add more heat into the cabin and noise into a tranquility, and yet alone the CO2 emissions. We needed an air conditioner that we can run, especially at night, cool off our cabin, get rid of the humidity and dampness, and we need all these in quiet. Kingfisher Marine Air Conditioner is born. Now, Tom, my colleague, is going to walk you through some animation to introduce the Kingfisher. If he can share the screen with us.
1 minute. All right, is it coming through? It should be popping up here.
You look good, Tom.
All right, cool. So just going to run through a couple of quick little animations that kind of highlight some of the components that are kind of novel and interesting about these units, as well as give kind of a real simple overview of how you might want to install something like this. So this is the MA37X12B. This is our latest and greatest version of the marine air conditioner. Again, it's fully DC power, 12 volts. And so what I'll show you here is a couple features. So one of the nice features that we have put into this unit is it has an all plastic drain pan. So condensation that forms on the unit when it's operating fall in the drain pan. There's no concern about any rust or any buildup. The drain pan is removable. So at some point in time, if it ever needs to be removed, it can be removed and replaced. The other nice thing about this unit is we've incorporated a number of features to improve the efficiency of the unit. So our goal, as Onat mentioned prior, is to be able to run these things without generators or without kind of backup power other than a solar system potentially, if you have that on your boat. So we've put some real smarts into this system and added some novel components that you don't normally see in a lot of the other air conditioners out there. One of which is an electronic expansion valve. So there's a lot of technical detail behind that, but in essence, what this allows us to do is to incorporate some proprietary algorithms and software to meter the flow of refrigerant and optimize the system for its performance. And so that optimization ends up resulting in reduced power load on your battery bank and longer run times. One of the other features that we've incorporated into the system is a variable speed, fully DC powered compressor. So the variable speed is nice because, again, allows for optimization and efficiency. It's fully DC, which is nice because you're not losing any kind of power efficiency converting from AC to DC. So pure DC operation. As we kind of rotate around the unit here, another major feature that we've tried to incorporate into this is serviceability. So while the units ship fully charged with refrigerant, we have incorporated both high and low side service ports into this so that you can get serviced by any kind of qualified AC technician, anywhere in the world, essentially. They should all be familiar with these types of ports. And so if ever anything does need to be serviced, it shouldn't be a real difficult challenge for you to find someone competent enough to do it. And then as we pan out here, another feature that we've incorporated into the V2 version of this system is a real compact electronics box. So it's a simple interface. It comes pre-attached to the unit, so it's all one piece. It's got 2 or 4 connections on it, power from the main battery bank, as well as a power lead that goes to your water pump. And then everything else is self-contained with inside. So this has our proprietary software and hardware in there. And again, full DC, no conversion electronics from AC to DC. It's full DC. So efficiency, efficiency, efficiency. Another nice feature here on the unit is we have a fully adjustable blower port. So this rotates continuously from fully horizontal to fully vertical. The nice thing about this is it gives you options for your installation. So we try and minimize any undue elbows or kinks in the ductwork that come out of the unit and into your cabin. And so this gives you some options there, which is a nice feature to have. And then the last thing I'll point out here is the electronics box itself is removable. So we've tried to give you mounting options for how you put the unit inside a certain enclosure. If that enclosure is too small, you might be able to remove the electronics box as shown, and we ship along with the unit some little feet that can mount to the electronics box and allow it to be surface mounted, somewhere, whether it be in the same enclosure or different enclosure, different space. The only thing that kind of tethers it to the unit is the cabling, which is about 4 feet long. So you can position that electronics box anywhere within a 4-foot radius of your unit. So that's kind of just a brief overview of the unit itself. Pretty compact, again, full DC power. The next little animation I'll show here is just an example of how you might install it. So this, not to say this is a one-size-fits-all kind of installation process, but this goes through the basics so you can kind of see how easy it is. So this particular video just shows an installation in a cabinet that could be inside your cabin or a galley or wherever you're looking to condition the space. So the basic components that you see from outside looking at the system here are a supply air register, which is where the cool dry air will come out. You have a thermostat, or what we call a user interface panel, that would be mounted in a convenient location. So this is what you would interact with to change the temperature, to change the fan speed, things like that. And then you have a return air register, which is what the unit will take, warm, humid air from the space that you want to condition, and then cool it and dry it off before it spits it back out into the cabin space. So as we kind of cut away some of the woodwork here and see what it looks like on the inside, you can see the unit at the bottom there. That's the air conditioner, and it's mounted, such that the evaporator is right behind that return register. That's where the air comes in from the cabin. And then you have some ductwork. So 4-inch standard, we recommend insulated ductwork. That's what runs from the unit out to the supply register at the top here. And then there's some thermostat or user interface cables that connect the user interface to the electronics box here. So it's a pretty simple installation. I'll kind of go into some further detail on what's required from an electrical and plumbing standpoint, but not a lot of space required for you to fit something like this into underneath a existing cabinet or into a small compartment somewhere. So in terms of the accessories needed to run the system, on the electrical side, there are 2 main hookups. I mentioned them earlier. One is just a direct power from your battery bank, 12-volt DC, goes right into the electronics box. The other connection that will need to be made is to provide power to a water pump, 12-volt DC water pump. And you'll see some details on what that does here on the next little slide here. There are 3 main plumbing connections that go to the unit. So there's a seawater discharge. So this is where water that is used to cool the air conditioner is discharged overboard. There's an intake for the same seawater. So this is what water is pumped from your water pump into the unit. And then there's the condensate discharge. So this is where any condensation from operating the unit in a humid environment collects in the drain pan, and then it's pumped out also overboard. We typically use 3/4 inch standard PVC plumbing to make these connections. Readily available, easy to find. All the connections on our air conditioner are 3/4 inch size, so common size. The main plumbing components that you'll need for the system to be installed are shown here. So starting with the seawater pump, which we talked about earlier. This is a 12-volt pump. We don't supply one with the unit, and reason being is your installation requirements vary from installation to installation. So some might require a larger pump than others because they're trying to pump a further distance away. So that one is something we can help you source, but we don't provide it in the box itself. That you'll also need a filter, so for the incoming seawater to filter out any particulate. And then sea caulk and scoop. So this is where below the water line you'll be bringing in seawater into the system. I should mention before going any further that these penetrations through the hull don't have to be brand new. If you already have existing penetrations, you can tee off of those and feed our system via those existing connections as well. So it's not like you have to put, dedicated penetrations into your hull for this system. Another important component is the sump pump. So this is what you probably already have in your system, but we would pipe the condensation into that sump pump, and that's what would spit it overboard. So pretty simple, not a whole lot of components needed to make the system work. And with that, I will turn it over to Onat.
Thanks, Tom. That was really great, detailed. Most of it is, as you know, is standard air conditioner installation, and that's especially if this unit is going to be a drop-in replacement, everything might already be in place. So just a little bit more on the unit now that we have looked at the 3D versions of it, but our Kingfisher has been designed to perform in the Caribbean. We followed ISO standards for the cruise ships that are going out in the Caribbean waters. We benchmarked 89.6 Fahrenheit incoming seawater temperature and basically thinking of 95 Fahrenheit outdoor temperature. By the way, remember last summer we saw in Biscayne Bay 100 Fahrenheit waters. After that, we tested to 102 Fahrenheit incoming seawater temperature, and we were still cooling it up. So typically 75% of our customers are in Florida. Our units are in use from South Africa to Tahiti. We proudly manufacture them here in Maryland. The secret sauce, as I should say, is our electronics and our own algorithm designed by Borders for marine applications. Our software and electronics give us an incredible efficiency compared to the other marine air conditioners. We are more efficient than traditional heat pumps. The maximum it will draw, the unit will draw is 25 amps. The minimum is 22 amps. Once it catches up to the set temperature, it will hover around 5-6 amps. Basically, at that point, it's pulling like a refrigerator on your boat. This unit is not going to cool your entire boat. This is to cool off your master cabin or a section where you can isolate from the rest of the boat. There's all specifications and other details are on the website in the frequently asked questions, or the specs are actually on where the unit is listed. And it's designed for do-it-yourself installation. I prefer not that you don't hire actually a technician like me to install these units. You don't have to deal with alternating current wires. You don't have to deal with any kind of electroshock or anything like that. Connect water, connect power, and it will start running. So let's take a look at it and play with the model here. So we actually rigged this up, and we're actually circulating seawater equivalent in this, I should say. Let me show you first some of the basic components that Tom shared as well. So we have seawater coming in at the bottom, seawater going out. In terms of the unit itself, the blower itself is adjustable as simply as rotating by hand. One of the key features that we are really excited about is that this unit, if space is an issue, this entire piece can slide out and can be mounted somewhere else. This is our demo unit, by the way. So what you would get is not this like this, especially the control panel itself is not a see-through box, but that's what's inside. So the unit actually comes with a package of other parts like these tabs that can be mounted on the unit so that the control box can be mounted separately. It also includes the Cat5 cable and RJ12 cable, and it will also come with some pads which will be necessary to put underneath the unit to prevent vibration going in. So I'm going to walk around and actually start running the unit. Here we have, this is our user interface. We're powering it up just to show you what's entails. So we have added 2 additional gauges here. This one you're seeing here is the actual incoming seawater temperature. The user interface is showing you the actual temperature at its ambient temperature. It's actually showing the humidity as well. And here you will see the temperature that's coming out of the blower. So we're going to turn on the AC function actually, and let's cool it off a little bit more. So I don't know if you can hear it, but the compressor has kicked in. And it will take about 12 to 15 minutes for it to stabilize, figure out, gather all the data, and start synchronizing all the other components. But most of it is going to be about the compressor needs to circulate some oil so that there's a warm-up stage that's going on. So the compressor itself is a variable speed compressor. So it actually, we are able to throttle it up and down. And that gives us a huge advantage in terms of the energy savings. Whereas other air conditioners will be on and off. Those are the 2 loads that they know. So right now we're gonna keep it running for a few more minutes. I just want you to see it. In terms of the real usage, we're just gonna see what the average is. So right now it's at 16 amps. As I mentioned, it will average about rate. Basically, once it catches up, the amperage drop is actually going to drop down significantly. That's to demonstrate that. We can even let's assume that it caught up in the temperature. Let's boost it up. You will see that once it knows at the temperature, it will start adjusting itself, the speed of the compressor. And then it's already dropping down in terms of the usage. I don't know if you can see that, but that's the actual amperage right now. We are able to just to give you a benchmark, in typically 90-degree incoming seawater temperature, we are easily can maintain 20 to 25 Fahrenheit delta. That's basically is the difference between the ambient temperature and the air coming out of the blower itself.
Copy
We're
that.
already down. It's going to drop down. Let's push it back down to a little bit more. So amperage is going to go up a little bit. I think that now was asking something. Can you see the screen or?
Yes.
Okay.
All right. Well, that's
We are already down to 61 actually, and just so far so good.
fantastic. I'm sure that there's many questions in the audience here. So are you ready to face our harsh questions? Are you ready for them?
For sure.
All right, good.
I'll lower the fan a moment.
Yeah, we're just gonna, by the way, it says just to mention again on the user interface side, I want to mention a couple of things. It's got 3 different levels of speed in terms of low, medium, high. It's going to handle up to 280 cubic feet of air in terms of the CFM. I'm sorry, on high. That's fairly high. The blower is actually quite strong in that sense. It's a standard 4-inch ducting. All the parts that you would need is actually available in any home store. and it's got cool features like sleep timer. If you want to set it up for like 2 hours, you turn on the unit, set it to a certain temperature, run it for 2 hours. It will shut it. You set it for 2 hours, and it will shut itself off, so that it doesn't drain the battery overnight. And what we would typically recommend is actually if you have like a 200 or 300 amp hour battery bank, that's enough for this unit to keep up with this unit, as well as the anchor light, the refrigerator, cabin lights, and the radios that you might be running at the same time simultaneously overnight. So on that note, I'll be ready for your questions.
All right, well, I'll get started just because I'm a curious guy. So is it intended to be used continuously too, or do you recommend a shutdown period during the day?
No, you can use it if you have the power capacity. We will typically recommend like having 300. We will recommend 250 watt solar panels. If you have that kind of solar panels, you can run this 24/7.
Okay,
So
copy.
it can be used continuously. It will just know what it needs. It will adjust itself, and it will know what it needs to do in terms of the unit itself.
What size wires, 12-volt wires, what gauge size do we need to run? I mean, I know it depends on the length, but what do you recommend?
Right. So for those, the instruction manual comes with its ABYC table. We want you to follow the ABYC table. The units come with a short pigtail that's a 10 gauge in terms of power connection. After that, you basically depends on how far your battery bank is to the units. You will have to follow the ABYC tables for the gauge of for the wire that you need. But typically, within an installation like this, we would recommend the instruction manual actually covers this as well. We would recommend putting a 30 amp breaker before connecting to the rest of the boat to isolate this unit by itself.
All right, my curiosity is good. Anybody else got any questions for Onat? Please come now.
Yeah, this is Joe Christensen. I notice a lot of air conditioning units are rated like with a BTU number. What would be the BTU equivalent of this?
Sure, 5,000 BTU is equivalent. It's actually 5,100, but 5,000 BTU. So that's a very good question. In terms of air volume, it will handle about 350 cubic feet of air volume. So that makes for a decent size aft cabin or forward cabin on a 44 foot boat. In terms of air volume, to be able to come up with a sizing, you would have to just multiply width, length, and height, and then you take out the furniture out of that equation. Yeah, I mean that's typically for cruisers. We are talking about larger boats, so this would basically be for the cabins, your master cabin.
Thank you.
Now, obviously, you might be working on a larger unit, would be my assumption.
So yes, this is a product that we wanted to bring to the market as soon as possible, because most of the time the inquiry is like, well, we're at anchor and sweating and we want to run it especially at night. That has been what we have been hearing in the marketplace, and we focus on this. We have plans to introduce other ones. The voltage might be going up. We also have it might be going up because the trend is going towards electrified powertrains, and when that's the case, the battery banks are already at 48 volts. So typically, we might, as the largest size, if we can get to that level, we are talking about at that point 1.5 ton units. That's more than enough to cool off an entire boat.
Question. This is Maciek. So kind of opposite to what Dietmar was asking. If this were to run only for the night, so it's hard to keep the cabin closed all day, right? So we'll probably turn it off during the day and turn it on for the night. How quickly can it cool down a cabin from air temperature of say high 90s?
Yeah,
to-
so the algorithm is different than regular air conditioners. So what is happening is that most of those conventional air conditioners, marine air conditioners, are using controllers that are designed for residential purpose, and they're following a certain path as they go to start the process of cooling down a space. And what we do is we are moving it smartly, and we have bunch of levels we step it down at certain intervals. One thing you will notice right away is it will start taking out the humidity immediately. I am talking about within 15-20 minutes. You will see that the humidity will start to go down 5-6%. And that's makes a huge difference. There's a huge difference between 90 Fahrenheit temperature with 90% humidity and 90 Fahrenheit temperature and 40% humidity. You will immediately notice that, and then the temperature will start going down that will basically depends on the volume and the volume of the air that it needs to cool. And for sailboats, we're talking about sometimes even having the engine compartment right next to the aft cabin, which is basically having all that heat in there. So I would recommend start running this whenever you get to the anchorage, and then basically let it take off the humidity and the temperature down before you go in. We had a wonderful email from a customer in Tahiti. He was raving about how exciting it was to get into cool sheets at night.
Cool, dry sheets. Yeah. Yeah.
So it's exciting to hear and get feedback once in a while like that, and it's been thrilling as to like what people are just don't they're really surprised with the results actually.
We also have informational videos on our website that show the unit running and the humidity dropping and the temperature dropping.
That's right.
All right. Anybody else got any good questions for Onat while we got him here?
I got a few. So I recently installed a Maybrew unit. It's very similar to yours. So here's a few things that I found that I didn't like, though I do love the unit. So where you've got the air vent, I currently have Dometic units, right? So the air vent is high right, and coming off the Dometic, it is way low left. So changing it over from a Dometic, which I think most people are going to have on their boats, the moving the vent was kind of a pain because you had to get new venting material and what have you, and it goes from high to down low, so you've got kind of a zigzag. The other issue is on the other side, you've got the out for the water, and it's high and to the left or high and back, where the out for the water on the Dometic is right where the vent would be. So it's like the opposite side. So then I had to rerun all new, I guess the whatever that, it's not pipe, it's just like a hose. So I had to rerun all new hose, or I had to put a union in there. So I just reran all new hose. So I would love to see these 12-volt units put where the air comes out and where the compressor are completely, swap sides and have the out to a different location so it matches up with the Dometic. I think I have so many friends who have Dometics that want to switch to these, and they're like, yeah, it's kind of a pain because I got to deal with this, deal with that. And I don't know, it'd just be nice. The other thing that was a challenge was the controller that goes into the wall. You had to like totally modify your wall to do put in the other controller, which not the end of the world, but it could just be so easy. To me, I think these units should just be plug and play for taking out a Dometic, right? Because the Dometic they're just everywhere. So why not make it plug and play? I do think I like how yours is variable. I don't know if the Maybrew is variable or not, but I like how it would be variable. I think that is going to save you power. And I love the feature that you've got for humidity. I can feel the humidity drop in my room, but I don't measure it, right? It'd be nice to know on my unit, hey, is it 20 or 30% less humid? So I think that's a super cool feature that you've got there. I guess my one big question for you guys is all my units are 12,000 BTU on my boat currently. And they're Dometic except for one Maybrew. And I've got 5 other units on my boat that I want to swap out, but I can't put in a 5,000 BTU where there's currently a 12,000 BTU. So when would you guys be coming out with like a 12,000 BTU unit?
Well, that's lots of comments and questions there. Firstly, I can't give you a time frame in terms of it. It's in the works, and we are on the electronic side. We have no problem. We can match it. It's the mechanical side, and some of it is also we are dependent on products that's available. It's available in the marketplace, and certain products are not easily found. And if we want to do things, they are going to be quite cost prohibitive. So there's that angle. In terms of the time frame on this, in terms of the larger size, we expect that later this year, but I can't give you a specific time frame. The one thing I can say though is, in terms of your comments about the BTUs, we are aware of number of boats that are using multiple units to cool off an entire boat. 3 of these units will be more efficient than a 16,000 BTU Dometic unit. Let's put it that way. It's especially being able to zone it like that. In terms of we're aware that, as I mentioned, like number of particularly catamarans that we are aware of, they have one for each. We have a few customers that ended up putting into multiple cabins, and in terms of the size, when you go up the size, you are also going to have to think about It's also going to depend on where you're cruising, what the environment is like. So there are all kinds of variables there, but in terms of sizing, what will fit, I can't speak for that in terms of without knowing more about your boat.
Stay tuned. Sign up for our email list and we'll keep you posted.
Sure. Yeah, I've got a 4-cab catamaran that, I'm down where pretty much, I think most people are kind of in the tropics, right? Caribbean, wherever, they're going to be around the same latitude or longitude or whatever that I am. It's humid and it's, 85 degrees. So I think that's pretty much where most of us are going to end up being.
Sure.
If we're cruising Alaska, we're not worried about AC,
Yeah, exactly.
at that point.
Yeah.
We're looking for a heat pump.
All right. Somebody else got a question. Anything at all? Oh, well, we're going to have a question about pricing and everything else, but anybody else had any technical question, install questions, warranty questions, how to get parts questions, anything of that nature?
Yeah, Chris on Sea Globe.
Hey, Chris.
Hey, good Friday morning or Thursday, whatever day ahead of you from Fiji. The question I had is you addressed it a little bit, but we didn't go over anything. Can you tell us because another big power draw for these types of units is the water pump. Can you tell us what kind of flow that you're looking for a sort of standard install? Give us some parameters.
Great question. So the unit needs only 1.75 gallons per minute. So that's almost half the volume of traditional air conditioners need. What most of our customers says, oh, I've got a 12-volt pump. I don't need that. So that's fine. We also would recommend the pump be rated as a continuous duty. There may be circumstances where the unit might be running while the compressor might be engaged while the water needs to be circulated for an hour or more. So it's not just a regular off-the-shelf simple pump. It should be continuous duty rated. There are multiple of these in the marketplace available. We will recommend keeping it under 5 amps. The unit powers that as well. In terms of for the sake of simplicity, there are units with simply 3/4-inch inlet and outlet pumps. And I should also add that we may be able to supply down the road. Yeah, we are in talks with another American manufacturer here in the US in terms of sourcing pumps from. So stay tuned on that front as well.
Okay,
All
thank
right.
you.
Question on.
Yeah. Go ahead, Mark.
Thank you. A follow-up question on the pumps. If, and I don't know what you did, Chad, maybe you can provide insight. We also have Dometics, and it's a 110 volt pump, but instead of having to buy a new pump, installing it, connecting it to existing through holes, would your unit be compatible with existing AC driven pumps that are already installed?
No, it's a DC. This unit is direct current only. There is no any kind of a transfer in terms of the AC conversion from AC to DC, DC to AC. Unfortunately, in your case, it would need a dedicated 12-volt pump. However, you can use existing Seacocks and you can even feed it into the existing ducting. So you can, whenever you're on the dock side, you can use your 110 volt system, alternating current system. And when you're offshore, you can continue to run this basically. And you can have a hybrid system basically.
So
Are you saying that
unit, oh, go ahead.
I was going to say, are you saying that the 5 amps for that water pump is coming off of your unit?
Correct. Correct.
Okay.
I didn't. Okay, got it.
Okay, because theoretically you could have that talk to a relay, which would then initiate your 110 pump, I would assume. But if you're pulling the 5 amps, yeah. Okay.
Well, just to be clear, it's 12-volt direct current coming out of the unit to power the pump.
Yeah, I thought as well. Basically, you have a controller that sends a signal through the pump. It's basically a relay, and if it's just a relay on off, why would it care? What actually powers the pump? I mean, unit says I need pump on. It just happens to be a 110 volt pump, but it's a relay. A relay is a relay. It doesn't care what the power source is.
Yeah, it's a question of efficiency, right? If you're at night, you want to keep your inverter on, or you want your 110 going. Probably the efficiency of a 12-volt system, if you're actually drawing from the batteries, is more efficient having a 12-volt pump than stepping up and then running a 110. So what are these pumps usually run? $300, $400, $500?
They draw well. You're right, but it's something that is robust. It's already plumbed in, and it only draws 1 amp on 115. So it's not horrible.
Yeah, well, again, I'm sure that's good feedback, but this is a 12-volt system, right? And it makes sense to be on 12 volt.
Okay.
All right, so now let's go to the interesting question. So what does your current system sell for? How soon can we get one? I have Suzanne on the hook for the next Anchorage. When I go back out, I'm supposed to buy one. So do tell us what the costs are and all the usual jazz.
Sure. The units retails for $34.99. We are basically about 2 weeks in terms of the lead time out. But just for the participants who have joined today, we're going to offer a 10% off with this promo code that I'm putting it out there.
All right, perfect.
For the date and timestamp, basically until March 31st. If you would like to place an order, go to our website, please enter this code and it will be 10% off from that price.
$3,150.
All right, that's
Yeah.
fantastic. Thank you
And
so
that's-
much.
In terms of the reality is that you just don't have to deal with installation costs. Otherwise, you're talking about an existing air conditioner plus a generator plus the inverter generator or soft start system, basically. That combination and then the labor of it, it's just when you add those up, it just doesn't make any sense to me. But
Yeah. One other question, and does it matter if you mount it forward facing or backward facing? Would you have that filter there, or does it matter?
It does, well, as long as this side evaporator is able to pull in the air from the cabin that it's going to cool from,
Yeah.
it doesn't matter how you orient it. As long as
Okay.
it gives you the most flexibility, adjusting in terms of your blower, and it's most of the time. By the way, I should mention, a number of customers came back to us and just said, like, we installed it under the berth, and it's quiet that they are able to sleep on it without a problem. So I want to emphasize that again, like it's a very quiet unit compared to anything out there. That's particularly was one of the key features that we were going after. Wanted to make sure that you're able to sleep while this is running.
Yeah, copy that.
Hence
Thank
the
you.
idea of not running a generator, basically.
All right, I'm pretty satisfied here. Does anybody else have any questions? We have set up a page under Panama Posse, which I'll send